So this is 7.4a, elementary algebra. We're going to do complex fractions. Now complex, I don't know why they call them that, because that just scares the bejeebers out of me when somebody says I'm going to do something really complex, especially when it has to do with fractions. But complex fractions are basically just one fraction over another fraction. Okay, and what do you do when you have fractions that are divided? You take the bottom one, flip it upside down, and multiply. Okay? And that's what you get. So that's what a complex fraction is. Now, sure, I do one with just numbers on it. That sounds really easy. But that's basically what you're doing there. That's called the division method. Now, there's also another method called the LCD method. And let's just go ahead and do that. Alright, I make that really thick just to show that that's a division sign, not part of the fraction. And it's always helpful to make that darker on your paper or whatever, just so you're reminded that you have a fraction divided by a fraction. Because if you write it like this, it's like, okay, what the heck is that? Okay, so makes it good to make that division symbol a little bit bigger. Alright, so the LCD method means that you look at the two fractions. Whoa, I didn't want to erase that, I wanted to circle. Look at the two fractions, denominators, and find the common denominator. What is the common denominator? Common denominator is 6. So I'm going to multiply the top by 6 and the bottom by 6, and I get 6 times 1 is 6 over 2, over 6 times 2 is 12 over 3. This top reduces to 6 over 2 is 3. This reduces to 4. And that's your answer. Okay, if I were to do the division method, you'd take 1/2 over 2/3, take that, flip it upside down, and multiply it. And you end up with the same answer. So, doesn't matter which method you use, sometimes it's easier to use one method over the other. Okay, and we'll get into when it is better to use one method over the other in a minute, but right now let's just try both methods on example 2. So I have 2x cubed over y squared. Okay, now I'm going to go and make the thicker division sign there. 4x over y to the 5th. Alright, so the LCD method says find the common denominator of this and this. Okay, the least common denominator of that, when there's just letters, is going to be the letter with the biggest exponent. Okay, so let's multiply the top by y to the 5th and the bottom by y to the 5th. So again, it's the one with the biggest exponent there. Which, if I multiply this through, you multiply these two, because this is y to the 5th over 1, this is y to the 5th over 1, if that helps. So that gives me 2x cubed y to the 5th over y squared times 1, over 4x y to the 5th over 1 times y to the 5th. Alright, now I can cancel. Notice I can cancel 2 of these y's with 2 of these, and that leaves me at 3 up here. And I can cancel all 5 of those with all 5 of those. So I'm left with 2x cubed over 1, because there's nothing there. So I'm just not even going to write the over 1, over 4x. Okay? And once I get there, I forgot to put my y cubed up here. Alright, now I can keep reducing. This cancels, leaves me 2 down here, right? 2 over 4 is 1/2. So what do I have here? I've got 1/2. And I've got 1x here I can cancel with one of these, leaving me 2 on top, right? And a y cubed. So this, in a simpler form, you don't need to write this 1, so you just have x squared y cubed over 2 for an answer. All right, so that is the LCD method. Let's do the exact same problem. Let's see if I can get rid of a bunch of this stuff. Let's do the exact same problem using the division method. 2x cubed over y squared over 4x over y to the fifth. All right, so the division method says we're going to take that, flip it upside down, 4x, and multiply. So let's go ahead and get rid of this stuff here. So this is going to give me 2x cubed y to the fifth over 4xy squared. And then 2 over 4 is 1/2. This x here cancels with one of those, leaving me 2 up on top. And this 2 cancels with 2 of those, leaving me a y cubed on top. And we don't need the 1, so it's just x squared y cubed over 2. So we got the same answer. I would say this one, for this particular one, was the easy of the two. Okay? So you can use both of these methods for every problem. So let me just give you a little bit of a hint on when to use which one. Middle of page 481. Okay, if the numerator and the denominator of the complex fraction are single fractions. So if we have something like 1/2 over 2/3, those are single fractions. Or x cubed y squared over 4, that's one fraction, over y over 2, that's another fraction. Then the division method is usually faster because we just take that, turn it upside down, multiply, and cancel, what we can. All right. If I have more than one fraction, so if in the numerator I have 1/2 plus x over 3 over xy squared over 2 plus 6y over x. Two fractions. So I have more than one fraction in the numerator, more than one in the denominator. When that happens, the division method is usually the best one. All right, so let's keep practicing some of these. We're going to jump to example 3 with multiple fractions on the numerator and multiple fractions on the denominator. Okay, so this is really x over 1 and y over 1. That's why they say multiple fractions, is because those can be written as a fraction. All right, so what we're going to do is we are going to do the division method and just give you an idea of what's going on here. So remember what I said about using the division method? You have to have single fractions in the numerator and the denominator to use that effectively. So we have to make those into single fractions. So we're going to take x plus 1 over y, our numerator, and we're going to combine those. Well, to combine them, we have to have common denominators. And if you'll remember when I talk through this, how to do that. I have a 1 here, I have a y there. I am missing a y here. And to have a common denominator, I'm going to need to have a y there. So I put one here and put one up here. Now I look over here. I have a y, but I don't have a 1. Well, 1 doesn't do anything. If it makes you feel better, you can put a 1 there, but it doesn't really do anything. So now what I do is I add my numerators, x, y, plus 1 over my common denominator. In this case, it's y. Okay, so now I have a fraction in my numerator, xy plus 1 over y. Line. Now let's work on this bottom here. Alright, so on the bottom, I have y plus 1 over x. Okay, so y over 1. So what am I missing over here that I have here? An x. So an x on top, an x on bottom. What do I have over here that I don't have here? Well, again, I have a 1. You can multiply it by that 1 if you want. Doesn't do anything. So I combine those, xy plus 1 over the common denominator of x. And that's what goes here. All right. Not too terribly hard yet, I don't think. Now, since I have one fraction here and one up here, now I can take this bottom fraction, flip it over, and multiply it. So I'm going to take my top fraction times, and I'm going to flip this one over. Okay? Now, one of the things, if you remember, when I have a plus sign, that's locking whatever's here with whatever's here. So if I can't cancel unless I cancel the whole kit and caboodle here. So I'm going to cancel that with that whole thing, and I'm left with x over y. Okay? Now let's do the same problem using the LCD method, and you'll see that you get the same answer, and you're just going to have to decide which one is easiest for you. So what I'm going to do is I'm going to look for, make this a fraction, make this a fraction. You know, if it makes it easier, go ahead and do that. It does make it easier for me, just seeing all the fractions. All right, so what's the common denominator of this and this? Well, it would be xy. Whatever this x or denominator is times whatever this one is. So what I'm going to do is I'm going to multiply this whole thing by xy and this whole thing by xy. All right, so let's distribute. Xy times x is x squared y plus xy over y. Okay, so that's this, and then I multiply it by this. Now let's do this one. Xy squared plus xy over x. Okay? Looks a little rough there, but it's really not too bad, because what can we do here? I have a y here and a y here. I have an x here and an x here. So now I have on the top okay? Now, let's look at my numerator, see if I can simplify it. I can factor an x out of there. And I can factor a y out of this. Holy smokes, I can cross that out, and there's my answer, just like I got when I did the division method. So, gosh, I know these can be confusing, but you pick the method that seems to be the one that works best for you. Now again, middle of page 481, there's two different things on, kind of give you an idea of which one is going to be the easiest depending on the fraction. So we'll keep going in the next video and do another couple and then look at the problem set. So that's it for 7.4a. We'll do 7.4b in just a minute.